Good evening, everyone. So, welcome to my YouTube channel, Max Akram. So, today we are going to see another important question. Let's see what is that question. If if A, B, and C are independent independent events, then so that so that A union B and C are also independent. Let's see its proof. We are required to prove that probability of A union B intersection C is nothing but probability of A union B into probability of C. That mean this will mean that mean A union B and C are independent. So we need to prove this, and that will mean that it is A union B and C are independent. So what are the given? So let's see its left hand side. Left hand side I am taking. So what is left hand side? Left hand side is A union B intersection C. How I can write this? I can write A intersection C union B intersection C by distributive law. Distributive law. Okay. Now we can use addition formula. Probability of A intersection C plus probability of B intersection C minus probability of A intersection C intersection B intersection C. Okay. So what is this? Probability of A intersection C plus probability of B intersection C. So what will be this? This will be probability of A intersection B intersection B intersection C. Okay. So what we can write? A intersection C plus probability of B intersection C. And what will be this? Because C is coming two times, so it will an intersection we are taking. So this will be this. Okay. Let's say it one. Okay. Now A, B, and C are independent. We have what it means. We have probability of A intersection B is equal to probability of A intersection probability of B. Probability of A intersection C is equal to probability of A into probability of C. Probability of B intersection C is equal to probability of B into probability of C. And probability of A intersection B intersection C is equal to A inter probability of A into probability of B into probability of C. So we let's say this is 2. So from 1 and 2, we get what we get left hand side is equal to P A union B intersection C. What is this? You put all this value in equation 1. So this was earlier probability of A intersection C, probability of B intersection C, and this was probability of A intersection B intersection C. From 1, we have this one. Now we are using second equation. What is this? Probability of A intersection, probability of C, and this is probability of B intersection into probability of C, and this is probability of A into probability of B into probability of C. So we can take probability of A common. Then this will be probability of C. Sorry, we can take probability of C common. Then this will be probability of A plus probability of B minus probability of A into probability of B. So what will be this probability of C? So we can write this probability of A plus probability of B. What is this part from equation 2? Probability of A intersection B. So what is this formula? Probability of A union B. So that means probability of A union B into probability of C. That is right hand side. So this implies A union B and C are independent unions. So prove. So it is proved. So today's question up to this, if you have any problem related to this, you can comment on my YouTube channel, like, share, comment, and subscribe my YouTube channel. So thank you very much for today's question. Thank you very much. We will see you in next question.